Welcome back, mathematicians. In this video, we are going to discuss the unit circle. So what we're planning to do here is redefine our trigonometric functions when we're dealing with the unit circle. Previously, we had on the coordinate plane an angle, and let's make the terminal side of this angle in quadrant 1. And we had a circle centered on the origin. And the point where the circle intersects the terminal side, we're going to label as the ordered pair of x comma y. Now, prior to this, we would say that the distance from the center of the circle, which would be the vertex of the angle, to that point is going to be a distance of r units. What we're saying now is that this will be a unit circle, which means that r is equal to 1. So again, previously we would have said sine of angle t, t being this angle right here, would be equal to y over r, the ratio of y and r. But now we're saying since r is equal to 1, because this is the unit circle, this is equal to y over 1, which is just equal to y. So sine of angle t is equal to y. Likewise, cosine of angle t is equal to x. Tangent of angle t is still equal to y over x because tangent was never in terms of the side of r. Cosecant of angle t is equal to 1 over y, which is the reciprocal of sine. Secant of angle t is equal to 1 over x, which is the reciprocal of cosine. And cotangent of angle t is equal to x over y, which is the reciprocal of tangent. Let's now look at our 30, 60, 90 degree and 45, 45, 90 degree triangles and analyze how those are incorporated into the unit circle. So let's start with our 30, 60, 90 degree triangle. I'm going to let this vertex of this triangle be 30 degrees. This vertex will be 60 degrees. And this will be my right angle. Which means that according to my 30, 60, 90 degree triangle, I know the side value opposite to the 30 degree angle is 1. The side value opposite to the 60 degree angle is square root of 3. And the hypotenuse will be a value of 2. What I would like to have happen is I'd like to scale this triangle back by a factor so that way the hypotenuse is equal to a value of 1. I will scale it back by a factor of 1/2, so multiply by 1/2, and what I get is a hypotenuse of 1. If I do that to the hypotenuse, I have to do that to all sides so that they are similar triangles. So I will multiply this side by a value of 1/2, resulting in 1/2, and multiply this side by a value of 1/2, a factor of 1/2, getting square root of 3 over 2. What I now know is that for the angle of 30 degrees, the point where the unit circle intersects the terminal side of this angle for 30 degrees will be equal to the x-coordinate of square root of 3 over 2 and the y-coordinate of 1/2. And again, that comes from the horizontal distance here. So the horizontal side or the adjacent side of this triangle according to the 30 degree angle is square root of 3 over 2 and the vertical distance is 1/2. I can also use this triangle to analyze the 60 degree angle. So for the 60 degree angle, I know that the point where the terminal side of the 60 degree angle intersects the unit circle will be at an x-coordinate of 1/2 and a y-coordinate of square root of 3 over 2. Now this is assuming again that this is the unit circle, which means the hypotenuse or radius is equal to a value of 1 for each of these. Now going to my 45, 45, 90 degree triangle, I know two angles are 45 degrees and I know my third angle is 90 degrees. I know that the sides opposite the 45 degree angles are going to be a value of 1 and the hypotenuse will be a value of square root of 2. I again would like to have the hypotenuse to be a value of 1, so what I will do is multiply this radius by a factor of 1 over square root of 2. This will then give me a radius or a hypotenuse of 1. I'm going to do the same thing to both the other two sides, so I multiply by 1 over square root of 2. This gives me a factor or value of 1 over square root of 2. I then need to rationalize the denominator, and so I get square root of 2 over 2. I then repeat the same process for the other side, and I still get that square root of 2 over 2 value. I can now use that information to analyze the 45 degree angle and where it intersects the unit circle. Again, the unit circle meaning that this radius or that distance from the origin to the point where the terminal side intersects the unit circle would be a value of 1. As a result, the x-coordinate of that ordered pair will be square root of 2 over 2, and the y-coordinate will also be a value of square root of 2 over 2. If I then put those three diagrams together, overlapping each other in the same coordinate plane, what I end up getting is the 30-degree angle, the 45-degree angle, and the 60-degree angle. And I see that the points where the terminal side intersects the unit circle will be square root of 3 over 2, comma 1/2, square root of 2 over 2, comma square root of 2 over 2, and 1/2, comma square root of 3 over 2. What I can then do is reflect that first quadrant over into the other quadrants, and what you'll notice is that the only thing that changes are the signs of the x-coordinates and or y-coordinates based on the fact that they are in now the second quadrant, third quadrant, or fourth quadrant. So remember, the second quadrant, all the x-coordinates will be negative, y-coordinates will remain to be positive. In the third quadrant, both x-coordinates and y-coordinates are negative, and in the fourth quadrant, x-coordinates will remain positive, but y-coordinates will be negative. But you'll notice otherwise, we have the same ordered pairs. When the terminal side intersects the unit circle on an axis, we get an ordered pair of 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And so this, when you combine it all together, is the unit circle. Notice I also have all the angles, not just in terms of degrees, but also in terms of radians as well. And so now this is something you can use to evaluating trigonometric functions for all angles that are multiples of pi over 6 or pi over 4. Let's now find the exact value of each of the 6 trigonometric functions if point P, which is equal to the negative square root of 2 over 2, comma, negative square root of 2 over 2, is the point on the unit circle that corresponds to the real number t. So t is the angle. And while we could actually determine the angle, the specific angle that corresponds to this point on the unit circle from the picture that we just discussed, that's not really what it's asking us to do. What we are being asked to do is evaluate the sine or find the exact value of the sine of angle t. And what we know is, again, in a prior lesson, we determined that sine of angle t is equal to y over r. But now we know the value of r because it does say that this point is the point on the unit circle that corresponds to the real number t, which means that we know this is equal to the y-coordinate, where the terminal side intersects the unit circle, which for this point is negative square root of 2 over 2. Cosine of angle t, likewise, is going to be x over r, but because this is the unit circle, it's just equal to x, which is equal to negative square root of 2 over 2. Tangent of angle t is equal to y over x, which is equal to negative square root of 2 over 2 over negative square root of 2 over 2. Now, because those two ratios are identical, we know that the ratio of the x-coordinate and y-coordinate in this case will be a value of 1. Let's now go ahead and find the reciprocal identities. So we can say that cosecant of angle t is equal to 1 over the negative square root of 2 over 2, which is equal to negative 2 over the square root of 2. And then if you rationalize the denominator by multiplying by square root of 2 in the numerator and denominator, what we end up getting is negative square root of 2. Repeating the same process for secant, we have secant of angle t is equal to 1 over negative square root of 2 over 2. And we just did this so we know that it results in negative square root of 2. Finally, we have cotangent of angle t. And we know cotangent of angle t is equal to x over y. Now, what we could do is find x over y, or we could do the reciprocal of tangent. Since tangent is equal to 1, the reciprocal of 1 is still 1. So we've now found all 6 trigonometric functions for this point P, which is the point where the terminal side of the angle t intersects the unit circle, which means that automatically our value for r is 1. All right, guys, good luck.